Africa is undergoing a dramatic transformation, a process so extraordinary that it's reshaping the continent itself. The Earth's crust beneath East Africa is breaking apart, tearing one of the largest landmasses on the planet into pieces. The Somali and Nubian tectonic plates are pulling away from each other, and a rift is expanding at an almost imperceptible rate, and it's giving way to an ocean that would take the world with it. In this video, we're going to bring you all the information about what's going on, and if there's a way we'd come out of this in one piece. The event that triggered global awareness, the 2005 Dabbahu eruption. The 2005 Dabbahu eruption. The seismic activity leading up to the 2005 Dabbahu eruption was nothing short of extraordinary. In September of that year, the Dabbahu area, situated along the Afar Depression in Ethiopia, began experiencing a cascade of earthquakes, over 130 recorded within a single week. These tremors were not minor events, they were measurable, powerful precursors to an unfolding geological phenomenon. Communities living in this remote area were both alarmed and bewildered by the intensity and frequency of the quakes, which caused the earth to rumble continuously. For residents who had no warning or context, it seemed as though the ground beneath their feet had turned volatile overnight. Each quake was a signal, a momentary burst of energy released as the Earth's crust pulled apart. Beneath the surface, tectonic plates were tearing from one another, and magma was surging upward into the fissures created by their separation. The scientific community took notice, as instruments recorded this rare alignment of seismic and tectonic events, and an unprecedented rifting process was set into motion. While small earthquakes are common in tectonically active zones, such a concentrated sequence pointed to a much larger event brewing underground. On September 26, 2005, the Dabbahu volcano erupted. Magma pushed to the surface with violent force, ejecting ash, molten rock, and gases. While the eruption was not explosive by global standards, its sheer geological significance was unmatched. The event caused massive fissures, cracks that split the earth in ways visible to the naked eye. As a direct result of this activity, approximately 6,300 people were forced to flee their homes, seeking shelter as far away as possible from the unstable land. Entire families were displaced, and communities reliant on agriculture were thrown into chaos as livestock was destroyed in significant numbers because of the sudden upheaval. The loss of livestock exacerbated the human impact of this disaster. The displaced communities faced immense challenges in the aftermath. Food insecurity became an immediate concern, as did access to clean water. Relief efforts struggled to reach some of the most affected areas, further showing us the vulnerability of those living in the Afar Depression. Yet, amid this human suffering, a global community of geologists and seismologists had their eyes fixed on what the region was revealing about Earth's inner workings. What made the 2005 Dabbahu eruption more than just a regional disaster was the scale of geological transformation it triggered. In the days following the eruption, 37 miles of fissures opened up across the Earth's surface, stretching the landscape like a wound tearing deeper. These fissures weren't just shallow cracks. They extended dozens of feet deep, revealing molten rock and thermal activity. The Earth, in real time, was ripping itself apart, forming a rift that would continue to expand. The displacement of the ground was unbelievable, with sections moving several meters within mere days. Satellite imagery and ground observations showed dramatic shifts in terrain that seemed almost surreal to those witnessing it. For scientists, it was a vivid example of plate tectonics, the massive yet invisible forces of the Earth, in action. The rifting was driven by the divergence of the Somali plate and the Nubian plate, two tectonic boundaries under incredible tension. As these plates drifted apart, the thin crust overlying them fractured, creating pathways for magma to rise to the surface. The Dabbahu eruption became a rare opportunity to observe rifting on a human timescale. Unlike most tectonic processes that take millions of years, the activity at Dabbahu unfolded over days, weeks, and months, allowing scientists to document and analyze each step of the process with unprecedented precision. GPS sensors and seismic equipment captured data showing that the 37 miles of fissures represented the initial stage of an ocean-forming rift. The Afar region was, essentially, laying the groundwork for the eventual creation of a new sea. These findings shed light not only on the tectonic processes governing the area but also on similar events that might have occurred millions of years ago during the splitting of ancient landmasses like Pangaea. This modern-day rifting provided a time-lapse view of Earth's evolutionary processes, offering critical insights into how landmasses fragment and oceans form. The Dabbahu event illustrated that Africa's rifting wasn't theoretical or anecdotal but a vivid, undeniable fact. It demonstrated how the Somali and Nubian plates, previously considered locked, could actively tear apart with enough tectonic stress. Magma, surging from below, acted as a force multiplier, pushing the plates even further apart. For researchers, this alignment of forces was a textbook case study for understanding the mechanics of plate tectonics. While the 2005 Dabbahu eruption marked a turning point in scientific awareness, it was just the beginning. Subsequent studies and ongoing tectonic activity revealed even more about how this rifting process would shape the continent and its people in the coming millennia. But what makes the Afar depression so unique, and why does this region seem destined to transform Africa's geography? Understanding the East African Rift. The East African Rift is one of Earth's most striking geological features. Understanding the East African Rift, stretching roughly 3,000 kilometers from the Afar Depression in Ethiopia down through Kenya, Tanzania, and into Mozambique. This vast rift marks the boundary between two tectonic plates. The Somali plate, drifting southeast, and the Nubian plate, moving northwest. It isn't just a line on a map. The rift is a dynamic, evolving feature where the Earth's crust is actively breaking apart. The process began millions of years ago and continues to unfold before our eyes. Scientists often describe this zone as the most profound example of continental rifting on the planet. What makes the East African Rift particularly unique? How the rift works is that it's not just splitting the African continent in two, it's also creating entirely new geological structures, like valleys, fissures, and even future coastlines. Unlike the relatively slow tectonic shifts happening in many other parts of the world, this rift is active enough to be observed in human timeframes. The East African Rift owes its activity to one key driver, magma. Below the Earth's surface, magma wells up from the mantle, intruding into the rift and creating pressure that pushes the Somali and Nubian plates apart. As these plates drift away from one another, the crust in the rift zone becomes thinner and more fragile, forming fissures and fault lines. Magma intrusion is a core mechanism of this process, as molten rock finds its way into these fissures, cooling and hardening to form new crust. Over time, this creates a continuous cycle of destruction and renewal. Older crust is broken apart while new crust is added in its place. The East African Rift is, in effect, a conveyor belt for new land formation, a phenomenon more commonly seen at mid-ocean ridges under the sea. But the forces shaping the East African Rift extend beyond magma. Gravity also plays a key role. As the rift expands, massive sections of the Earth's crust sink under their own weight, forming dramatic escarpments and deep valleys. These valleys often fill with water, as seen in the region's iconic lakes like Lake Tanganyika and Lake Malawi, which trace the rift's trajectory. In total, this ongoing activity has already created one of the most geologically diverse landscapes on Earth, filled with volcanic activity, hot springs, and fertile soil. Over time, the forces pulling the Somali and Nubian plates apart will widen the rift to the point where water begins flooding the area, likely from the Red Sea and Indian Ocean. When this happens, Africa will split, and a new ocean basin will form between the Eastern Horn and the main body of the continent. This isn't mere speculation, it's an inevitability dictated by the principles of plate tectonics. Similar processes have happened before, most notably during the breakup of the supercontinent Pangaea. Around 180 million years ago, the Atlantic Ocean began to form when tectonic plates tore apart landmasses that would eventually become Africa and South America. Today's East African Rift is a smaller-scale version of that ancient process, but the end result will be no less dramatic. Though the creation of this ocean will take tens of millions of years, current activity shows we are witnessing its earliest stages. Some segments of the rift already dip below sea level, particularly in the Afar Depression, where magma-induced subsidence continues to lower the land. Satellite observations have shown that the rift is widening at an average rate of a few millimeters per year. Over geological timescales, this steady movement will result in the rift becoming unrecognizable from what it is today. When the ocean finally forms, it will not only change the physical geography of Africa but will also reshape the global map. Future generations may recognize a continent split into two distinct regions, with coastlines bracketing the newly formed ocean. The formation of a new ocean will dramatically alter the climate, ecosystems, and biodiversity of the region. Coastal areas will emerge where none previously existed, leading to new opportunities for marine habitats. However, this transformation will also pose significant challenges for human populations, particularly those reliant on the land for agriculture and livelihood. In places like the Afar Depression, where fertile valleys and lakes provide sustenance for communities, the flooding caused by ocean encroachment will likely displace thousands Volcanic activity associated with the rift could also intensify as magma continues to rise and erupt, potentially threatening nearby populations. Moreover, the changing geology may influence local climates by affecting wind patterns, rainfall distribution, and access to freshwater resources. The East African rift serves as a vivid example of tectonic forces reshaping our world. Yet, the ongoing changes in this region are part of a larger, more intricate geological narrative, one that hinges on the unique characteristics of the Afar Depression, the epicenter of rifting activity, the engine behind the rift, dynamics of the rift. At the heart of the East African rift's dramatic transformation is the slow but relentless movement of Earth's tectonic plates. The Nubian plate, which makes up most of the African continent, and the Somali plate, representing its southeastern portion, are pulling away from each other at a rate of up to 2 inches per year. Though seemingly negligible on human timescales, this divergence accumulates over millions of years, resulting in massive structural changes to the Earth's crust. This movement is driven by convection currents deep within the mantle, where heat from Earth's core creates circulating currents of molten rock. These currents generate enough force to fracture the overlying crust, creating a divergent boundary between the Nubian and Somali plates. Unlike convergent boundaries, where plates collide and create mountains, divergent boundaries like this one are zones of separation, tearing the surface apart to create new landscapes. The East African rift is essentially a nascent version of what occurs along the world's mid-ocean ridges, like the Mid-Atlantic Ridge. Here, as the plates diverge, magma wells up from the mantle to fill the void. As it cools, this magma solidifies to form new crust. Over time, this cyclical process will expand the rift, eventually creating a full-fledged ocean basin. The mechanism is both simple and profound. As magma pushes upward, it weakens the lithosphere, causing it to fracture and thin. These fractures develop into fault lines and fissures, creating steep valleys and escarpments. In the East African rift, the process is evident in regions like the Afar Depression, where active magma upwelling creates visible geological features, from basaltic plateaus to volcanic cones. This phenomenon of crustal creation is not unique to modern times. Around 180 million years ago, a similar divergent boundary formed between what are now the South American and African continents, leading to the formation of the Atlantic Ocean. The East African rift offers a rare chance to observe this immense process occurring on land rather than beneath the ocean. The rift's progression is far from quiet. Seismic and volcanic activities are constant reminders of the forces at work beneath the surface. The tectonic stress generated by the diverging plates leads to frequent earthquakes, many of which are strong enough to alter the region's topography. For example, in the 2005 Dabbahu event, over 130 earthquakes struck within a week, providing a striking example of how these forces interact on a rapid timescale. Volcanic activity is equally significant. The East African rift hosts some of the world's most active volcanoes, including Erta Ale in Ethiopia and Ol Doinyo Lungai in Tanzania. These eruptions not only release vast amounts of magma but also reshape the surrounding landscape by depositing new layers of volcanic rock. Magma chambers beneath these volcanoes also play a critical role in weakening the crust, accelerating the rifting process. Another hallmark of the region is the formation of geothermal features, like hot springs and fumaroles, where heated groundwater escapes to the surface. These features signify the proximity of magma to the Earth's crust. Over time, the combined effects of plate divergence, magma upwelling, and seismic activity will lead to the formation of a new ocean basin. As the Somali plate continues to drift away from the Nubian plate, the rift will expand and eventually allow seawater from the Red Sea and the Indian Ocean to flood the region.